Good morning, everyone, and welcome to the March 2026 edition of the Southeast Monthly Climate Webinar, where we talk about the climate and special topics pertaining to the Southeast region. My name is Chris Fuhrmann. I'm the Deputy Director of the Southeast Regional Climate Center, and I'll be giving a climate overview of the past month. Our other speakers today are Dave Zierden from the Florida Climate Center, who will provide an update on drought conditions there in the state. We have Aaron Mayhew from the Southeast River Forecast Center, who will provide a water resources update. Pam Knox from the University of Georgia, who will provide an agricultural impacts update. And joining us today, we're pleased to have Jon Gottschalck from NOAA's Climate Prediction Center, who will be discussing what goes into the monthly and seasonal climate outlooks. So again, thank you all for joining us. Just a reminder, type those questions and comments into the question box at any time, and they'll be answered at the end. Also, a recap email of this webinar will be sent out with a YouTube link to the recording in the next day or so. All right, so let's get started with an overview of the climate. All right, so spring has definitely sprung across the region over the past several weeks, especially after what was a relatively cold and snowy winter for many of us. Temperatures so far this month are running about 5 to as much as 10 degrees above normal, especially across the northern part of the region. In fact, a number of locations are on track to record one of their warmest Marches on record, including places like Chattanooga, Nashville, Greensboro, Raleigh, Charlotte, Atlanta, Muscle Shoals, and even down in Florida in places like West Palm Beach. We go down into the Caribbean, temperatures are also running above average, with several locations across Puerto Rico and the Virgin Islands on track to record a top 10 warmest March. All right, next slide. So I know I just said spring has sprung, but honestly, some of the temperatures we've seen over the past few weeks might make you wonder if it's actually summer that's arrived. A great example is from March 11th, there on the left, when temperatures reached the upper 80s across Northern Virginia, with 90s across parts of the Carolinas. That's about 30 degrees above normal for this time of year. And on the right, we see that many locations have seen a record number of 80-degree plus days so far this month. And if we go to the next slide, we can look even warmer than that. We can look at locations that have hit 90 degrees already this year, including Tampa, which hit 90 back on March the 6th. That not only set a new daily record, but it also marked the earliest 90-degree day on record. That broke the previous record by a full 10 days. Fayetteville, North Carolina also recorded its earliest first 90-degree day on record back on March 11th. That beat the previous record by over a week. A day earlier, Jacksonville tied its earliest first 90-degree day on record, nearly 2 months earlier than normal. In addition, several other locations that you see there, Savannah, Gainesville, Valdosta, they all recorded or tied their second earliest first 90-degree day on record. So it has been quite warm here over the past several weeks. Okay, next slide. All right, so shifting gears to precipitation. Unfortunately, the story remains much the same as it has since late last summer. Many locations continue to run significant precipitation deficits. On the left, you can see that much of the region, especially Virginia and the Carolinas, is below the 25th percentile for precipitation so far this month. And that's contributed to longer-term dryness, which is reflected on the right, where many locations rank among their 10 driest periods on record over the past 6 months. Some notable examples include Macon, Georgia, which has received only about half of its expected rainfall over the past 6 months. Charlotte, North Carolina, which is nearly 10 inches below average, and they're experiencing their driest such period on record right now. And Charlottesville, Virginia, also approaching a 10-inch deficit, and that ranks as its second driest such period on record. Here in Raleigh, we've only recorded 1 day with more than an inch of rain over the past 6 months, and that makes it the third driest such period on record for the Triangle region. Now, while it's been dry in many places, you'll see that parts of South Florida have seen some beneficial rain over the past few weeks. We've had up to 3 inches or over 3 inches of rain in parts of the Keys and nearly 5 inches of rain around Fort Lauderdale so far this month. And across the Caribbean, we've also seen above average precipitation so far in the month of March. All right, next slide. All right, so looking at the drought monitor, we've seen a mix of kind of localized improvements and also some degradations over the past month. The most notable improvements occurred across eastern portions of Tennessee, Virginia, and South Carolina, where some areas improved by as much as 2 categories. At the same time, 1 category degradations were kind of scattered across much of the region, with the most widespread degradations in parts of Alabama and parts of Tennessee. Another notable development is the return of a small area of exceptional or D4 drought in the central panhandle of Florida and extreme southern Georgia, also including the area around Valdosta. Overall, abnormal dryness and drought continued to cover more than 95% of the Southeast Dunes region, with over half of the region experiencing severe drought or worse. Okay, next slide. All right, looking to the Caribbean, conditions remain in relatively good shape there. There's still a small area of lingering dryness along the southern slopes of Puerto Rico, but dryness has now been removed from St. Thomas, and that leaves the Virgin Islands free of any drought or dryness as we head into the wet season coming up. Okay, next slide. All right, as we know, one of the big stories over the past few months has been, of course, the cold weather and the winter weather, which meant we haven't really seen much in the way of severe storms. In fact, this past winter saw the fewest number of tornadoes in the region in over 20 years. But now that the pattern shifted, we're starting to see more strong thunderstorms develop, and some of those have produced tornadoes. The first notable outbreak of the year in the region occurred on March 11th and 12th. That coincided with that stretch of very warm weather that we talked about earlier. A total of 32 tornadoes have been confirmed across the region. Most were in Alabama and Georgia. Another 10 were confirmed across the Carolinas. The strongest was an EF2 in Macon County, Georgia, which damaged or destroyed several homes and injured at least 2 people, one of whom was actually thrown from their home. Okay, next slide. All right, turning to ENSO. As we discussed last month, conditions are expected to transition from La Niña to neutral over the next month or so. There's about a 55% chance that neutral conditions will persist through the rest of the spring and into summer, and a greater than 60% chance that El Nino will develop later in the summer and continue through the end of the year. Now, you'll notice some of the probabilities later in the year exceed 80%, but we still haven't moved past that spring predictability barrier yet, so it's still a bit too early to place high confidence in some of these longer term projections. So we'll just have to wait and see. Okay, next slide. Okay, looking ahead to this weekend and early next week, temperatures are expected to remain above average across most of the Southeast. Dry conditions are also expected to persist, except across South Florida, where that wetter pattern looks like it's going to continue for a while. If we look on the next slide, as we move into next week and into next weekend, that pattern largely continues. So continuation of above average temperatures with the western portion of the Southeast and also South Florida continuing to trend a bit wetter than average. And on the next slide, as we look out to, there we go, look out to mid-April, the outlook continues to favor above average temperatures. Precipitation is also expected to be above average across most areas, although Florida is showing equal chances of above or below average precipitation in the longer term. Okay, also want to mention, since it's March, that our quarterly climate impacts report from this past winter is now available on our website. You can find that at the link at the bottom of the slide. It was a busy season. We say that, I feel like every season, but this winter was very busy. Lots of cold weather, lots of winter weather, drought, lots of impacts. So check it out if you want a synopsis of this past season, and also reach out to us if you have any questions or have any specialized data requests. And so since John's going to cover the outlooks, we'll go ahead and turn to the summary slide, which you can look at after the webinar. Want to acknowledge, as always, our service climatologist, William Schmitz, who does a phenomenal job putting a lot of this information together. And with that, I'm going to turn it over to Dave Zierden. He's going to provide an update on drought conditions in Florida.
All right, thank you very much, Chris. We'll go ahead and get started with the next slide. I don't want to brag about my fishing. Here in Florida, we're experiencing a really significant drought. As far as the drought monitor goes, that's been in inception since 2000. This is the worst drought we've experienced. We've got nearly 100% of the state as moderate to severe or even extreme exceptional drought. The exception is one little part of South Florida where they got 10 to 15 inches of rain last week. But if we look at D3 or severe drought and above, what is it, 72% of the state is covered in D3, which is the most since the inception of the U.S. Drought Monitor. So a very significant drought. We also have a small pocket of D4. This is the first exceptional drought in the state since 2012. So really significant conditions here in the state of Florida. And we'll go to the next slide. Start talking about some of the triggers for this drought. And one, over on the left, I show all the hurricane tropical storm tracks for the 2025 season. And you'll notice there are none in the Gulf of Mexico. There are no landfalls on the northern Gulf Coast or the west coast of Florida. Really no impacts to Florida or the southeast at all from the tropical season. And that's a two-edged sword. We escape damages, but at the same time, we lack the tropical rainfall that is a critical part of our climatology. Then there's another aspect also. When very strong hurricanes like Aaron and Melissa track offshore of the East Coast, that leaves us on the western side of these very strong storms where we have subsidence, amplified high pressure, drier conditions usually follow these storm paths. So that was one of the first triggers of drought back in late August, September. And the other big trigger was La Niña conditions, which started back in August and persisted through the entire winter. We're still in weak La Niña conditions according to the Niño 3.4 index. As Chris said, it's forecast to dissipate quickly in the next month or two, but we might still have some lingering impacts, which are usually a warmer and drier winter for Florida in the southeast. While the warmer didn't necessarily work out, the drier certainly absolutely did. So we'll go to the next slide. Talk about, we've seen this already. These are the 90-day rainfall departures for normal across the entire panhandle in North Florida. Deficits of 6 to 8 inches or more across that entire area. Lesser deficits down in the peninsula just because it's the dry season and we don't expect much rainfall during the dry season anyway, an average of 2 to 3 inches per month. You probably can't see it, but over on the right is the actual station data for departures from normal for the past 90 days. And you see the 7 to 8 inch range across all of North Florida. Lesser amounts in South Florida, but still significant given it is the dry season. So on the next slide, one of the major indicators and impacts are low stream flows. And all across the panhandle in North Florida, everywhere you see the dark brown dots, those are stream gauges that are in their lowest 5th percentile. And this is at the end of what should be the winter recharge season for North Florida, South Georgia, South Alabama. So this clearly illustrates we did not get the recharge that we needed this winter, and that could lead to big problems as we go into the summer time when evapotranspiration actually exceeds normal rainfall. So we'll keep a close eye on that. As we go to the next slide, here's just some photos of some of the impacts. Here's a spring on the bank of the Suwannee River, and the river is so low. If you can see those steps, that's where the pool of the spring should be. But right now, it's just a kind of a rapids that flow into the river that you can walk across. So significantly low stream flows. Over on the right, Lake Jackson, north of Tallahassee, they used to say it happened every 25 years that a sinkhole would open at the bottom of the lake and the lake would drain. And this would happen when the aquifer gets very low. Happened again this year. It's been happening more frequently, but here's a photo of that sinkhole and the dry lake bed. So next slide, we'll talk about the wildfire impact. Here in Florida, the Florida Forest Service has a great product for high resolution Keach-Byram drought index. Here's the current KBDI across Florida, values over 550, 600 or more across most of South Florida, and also the Big Bend area indicates a very high wildfire potential and very dry fuels. And on the next slide, we'll see some of the impacts of that. Just this past weekend, there was a 500-acre wildfire in Calhoun County near Bristol. It destroyed 14 or more homes, vehicles, one injury. Just a very significant wildfire. And then over on the right, earlier this month, we had the national fire in the Big Cypress National Preserve. This burnt over 30,000 acres. And when conditions really dry out and the natural fire breaks and wetlands dry out, that sets the stage for these large, uncontrollable fires. And that's what we've seen. Over 30,000 acres. It actually closed down Interstate 75 for a day or so because of smoke and the wildfire danger. So on the next slide, we'll just show some of the condition monitoring reports. You see several around the state. There's not a lot of them, but the ones that have been submitted are very, very dire. So we always appreciate getting feedback from the public in these Seymour reports. We'll go to the next slide and we'll talk about some agricultural impacts. Right now, the main one is range and pasture. We did not have enough rainfall this year for winter pasture to thrive much at all. Much of the cattle industry is feeding cut hay, which is very expensive. Here's a photo from Okeechobee County showing very dry pasture conditions, and even the watering pond is close to drying up. And we've seen many reports of that. Pam Knox can go into more detail. Grady County in Georgia, same thing. So that's the main agricultural impact right now. But as we go into spring and spring planting season, it's going to have a huge impact on row crops and others. So we'll go to the next slide and we'll talk about what's ahead. It's likely to get worse before it gets better. We are still in the Florida dry season, and over on the left I show the just normal rainfall for the month of April, where much of the peninsula can only expect 2 to 3 inches of rainfall during April, even in a normal year. The dryness continues up into South Georgia, the Florida Panhandle. It is one of the drier months of the year here. So we're not anticipating any real relief anytime soon. However, May 15th is the official start of the Florida convective rainy season with sea breeze interactions and such. The problem is if the rainy season doesn't start on time or is subpar, impacts can intensify quickly with rising temperatures and the summer heat and high sun angle. Also, even if La Nina was still in place, it really loses its influence over the southeast as we get into April and May, so it's really no longer a factor. But we're hoping for a robust beginning to the rainy season. Maybe with what Chris showed, South Florida will start seeing that, but other parts of Florida, it could even get worse before it gets better. So that's all I have. And with that, especially more discussion on stream flow and climatology, I'll pass it along to Aaron with the Southeast River Forecast Center.
All right, thanks, David. As you mentioned, my name is Aaron Mayhew. I'm with the Southeast River Forecast Center. And if we head to the next slide, we can look at some of the water resource and stream conditions. So on this first slide on the right-hand side, I've got the 30-day percent of normal rainfall. You can see that little stretch there across north central Georgia and Alabama, wherever they actually received more than normal precipitation, along with kind of central Florida, maybe St. John's, Riverside area, and down through South Florida. especially the tip of Florida where we saw 10 to 15 inches of rain down there one day. So you can kind of see that reflected a little bit in the 28-day average stream flow anomalies. I do need to make a note here, a disclaimer, with USGS Water Watch discontinued, their historical maps are no longer available. So this 28-day stream flow average is something we've produced here, and these data are experimental and provisional. That said, we've tried to replicate the methods that were done previously by the Water Watch folks. So the big picture here is, as he mentioned, North Florida Panhandle, you can really see the well below normal stream flow conditions. We've got about a third of our area, especially the Central Florida, North Georgia, Central North Alabama, where they received the rainfall, getting back up into normal stream flow values. But a whole 2/3 of the area is still below normal stream flow, and in fact, about 20% is extremely below. So things are not looking great out there in the stream flow category. If we go ahead and go to the next slide. And again, same disclaimer, these are locally produced, experimental to replicate the statewide stream flow runoff plots from the Water Watch. And we can kind of see the same story here for Alabama on the left, Georgia in the middle, Florida on the right. Alabama did see a bit of a peak up from our last webinar. They dropped well down below the 5th percentile, but then they've managed to pop back up a little bit, especially thanks to the north side of that state. However, we are still below normal in statewide runoff there. Georgia, same thing. It has seen some improvement, a little bit of rise there. They finally crept over the 5th percentile, but still much below normal on the statewide runoff. And Florida, you can see there, spent some time dry as dry as it's seen. There is a little rise there, but that's just to get back to extremely below normal. So things looking pretty rough there as well. Next slide. And it's pretty much the same story as we go through the Carolinas. Much of our area in Virginia is a good bit below normal. This particular graphic is for the entire state. So they have seen some improvement, but still, like everybody else, even with that improvement, remain in the at least below normal category. South Carolina's statewide runoff flirting right about the 5th percentile level, and same with North Carolina. Go ahead and go to the next slide. And with no surprise with the dry conditions out there and the overall lack of rainfall, our river forecasts are pretty much below action level everywhere. There was a little action level that snuck in there. Midville was above action for a little while, but it has, even this morning, already gone back under. And over the next 5 days, we're not forecasting anything else to even rise to action stage. Next slide. And here's just a look at the week of the year where we're at. We've kind of hit the peak and we're crested. We're on the downhill slide of that as we approach the drier summer months. But typically it is still, a somewhat active flooding week of the year, and we continue to just not see those levels. Go to the next slide. And even looking at the South Florida groups, where the typical flooding season is a little bit different from everywhere else. They do see a little bit of a peak here, but even with the rainfall that they've seen recently, the previous dry conditions are not showing up in the riverine flooding threats. Go ahead and go to the next slide. Overall, as they've talked about in some of the outlooks, and they'll probably be discussing here a little bit more later, we are transitioning out of La Nina, getting in towards end zone neutral. We'll see a little bit of the shift of that subtropical jet a little further south. That could bring some, more active thunderstorms, maybe some heavier convective events. The long range outlook model runs do show, at least at the 50% level, a handful of minor flood stages, probably a little bit lower than what we normally see this time of year, but there is some there. So overall, probably, a normal risk for flooding, but maybe pulled down a little more towards below normal just due to the dry conditions in most of the places. But, maybe we'll start to see a little bit of rain as we transition. But of course, the other concern is the fall time with El Nino in place, perhaps dampening some tropical activity and cutting off even more rainfall. So go ahead to the next slide. That should be it. Yep, so that's my summary. So I'm all done there, and I'll go ahead and pass it off to Pam.
All right, well, good morning, everybody. Good to talk to you. And David's already taken some of my talking points, but that's okay because drought has a lot to do with agriculture. So let's jump right into the first slide. Some of the impacts of recent conditions on agriculture, they really fall into two categories. One is related to the drought and the lack of rainfall, which David already mentioned. The other is the really wide swings in temperature that we've been having over the last few months. And, you know, some of those lows turn into frosts or freezes, and that's caused a lot of problems for agriculture in a lot of the region. We talked about that some already last month with the freezes in February, but we did have another round in March. And so those wide swings in temperature really have been giving the producers a hard time because they have to keep watching for these cold outbreaks to worry about freeze protection. And then the damage to plants is really a place where diseases and pests can really do bad things to the plants. And so they really have to watch for fungal diseases and so on and work to protect against those as we go forward. So the most notable freeze conditions occurred on March 17 and 18 in the middle of the month. And that was with another cold outbreak that came from the northwest. The first night was an advective freeze where the winds stayed up and it just brought this, this freight train of cold weather into the region. And then the second night was more of a radiative freeze where the wind calmed down, but with clear skies, a lot of heat escaped back to space. That's very typical pattern for the Southeast. And so there were a number of orchards that were affected by that. The picture I have on the top left there is from Jaymore Farms, which is just in the northeast part of Georgia, and they had their peaches in full bloom at the time of those freezes. I was watching very carefully. You can see they've got a machine there that peaches you can't really irrigate because they're too big, but they use wind machines to help stir up the air and keep things from getting quite as cold. I know they did have some damage, but they said that they didn't have a complete loss for sure. So they do expect peaches. Of course, peaches, some are blooming earlier than others are, so there's some variation in that. A little bit of freeze can actually do a little bit of thinning, which means that the remaining peaches are larger, which is probably a good thing. I did see one notice on Facebook from a blueberry producer up near Huntsville, Alabama, who said they got temperatures down to 23. And so they had nearly a complete loss of blueberries. Strawberries were mostly protected by covers, but some of the producers did note that it was so windy that the covers blew off and damaged the plants that way. And so they were debating about whether it would be better to just not even use the covers and take some loss from the freezes. And then the damage from the scattered rain, or the lack of rain really, that has caused problems with drought in some areas. The producer down in Grady County in southwest Georgia indicated that their ponds are completely dry and that other producers noted that they are out of hay completely. So they're having to purchase hay or they're going to have to get rid of some of their cattle to keep things going. And you can see the bottom picture on their slide shows some of the fungal diseases that can occur when you have cold conditions and you have dead tissue on those conditions. That's a real place where those things can form. So let's go on to the next slide. And this just shows you how warm the soil temperatures have been across the whole region. These 80-degree days really warm up the surface temperatures a lot. It's given people the urge to go plant really early. We've had corn and even cotton and I think some peanuts being planted because the temperatures have been quite warm. But it's a little dangerous to do that because if you get cold temperatures, then that really affects things that are going on as far as the plant growth goes. And then certainly when you have new seedlings in the ground and you have cold temperatures, they're more likely to see seedling diseases that need to be treated, or you don't have a very good stand and you might even need to replant. So that's something to keep in mind. Soil moisture, I'm sure you're not surprised, shows that it's been very dry across most of the region except for a little bit of eastern Tennessee, northern Alabama, and northwest Georgia. So if we go on, this is the chill hour graph for Fort Valley, which I've been showing all year. You can see that the total amount that we've gotten this year is very close to what we got last year, but it's definitely higher than the previous 2 winters. And it's definitely also well below the historic average, which is shown there with the yellow line. Not surprising since temperatures have been going up. This will be the last time I'll show this. Of course, everything's pretty much blooming already, so not really a concern. If we go on, I'm going to talk just a little bit about the freezing conditions. I showed 2 different maps here of the lowest 1-day minimum temperature. The one on the left shows from February 20 through March 21, which is when I did these slides. And you can see that anywhere that's green had a minimum temperature that was below 30. So that was basically all of the Southeast except for the Florida Peninsula and even partway into the Florida Peninsula. Just looking at the last 2 weeks, which includes that last freeze pattern on the right-hand side, notice it's a different color scale because it's a dynamically generated color scale. So anything below anything that's dark green or lower had a minimum temperature below 30. Again, a lot of the region, except for maybe some of the coastal areas, was covered by that freeze. And the only place that wasn't really was the peninsula of Florida. And so a lot of people were hit by that freeze. Not surprising, if you go on to the next slide, it shows you what the late spring freeze maps are. And we are now in the bright blue, the royal blue. So you can see the average last frost date for northern Alabama, northern Georgia, and a lot of upstate Carolinas is about this time of year. So that means would not be surprising if we had another frost. The last freeze at 10% shown in the graph on the right. That means 1 out of 10 years can get a frost as late as the last week of March. And you can see that stretches well into central and southern Alabama and Georgia and along the coast of South Carolina. So we are not out of the freeze season yet, although if you look ahead in the long-range forecast, I don't really see anything except up in the mountainous elevations. If we go on to the next slide, it shows the date of the last frost since 1991, so in the last 30 years or so, 35 years or so. And you can see that for most of the region, again, except for really coastal areas, the last freeze can occur in April. So we are not completely out of the woods yet, but a lot of people are planting. I did notice that some people who had planted early corn had frost damage, but the growing point was still below the ground. And so they think the corn will probably grow out of that. But it's going to slow development because they grow like crazy when it's hot, and then they just stop when it gets cold and sit there for a few days. And so that makes them more susceptible to seedling diseases. And then if we go on, I just wanted to point out here the first leaf and first bloom indices everywhere in the Southeast now has had their first leaf. Some of you for quite a while, especially. First bloom, this particular index is related to lilacs and honeysuckle. We don't really have lilacs in the Southeast because it doesn't get cold enough. But my honeysuckle in Athens is definitely blooming. And so you can see that the northern part of our region, especially Virginia and the higher elevations, still are not seeing, they're starting to see some of the early blooms that aren't captured by this index, but they're definitely not all the way into full spring yet. This week in Athens, we've had the dogwood and the azaleas come out, so it definitely feels like spring. Go on. This is my summary. You could go ahead and look at that later. Again, the big messages are the effects of the drought and the effects of the freeze that we had in mid-month. So with that, I'm going to go ahead and pass it off to Jon Gottschalck and let him talk about the seasonal outlooks.
Thank you very much, Pam. And I also want to thank the organizers for the invitation to speak today. I really appreciate it. I'll be talking about NOAA's CPC's monthly and seasonal outlooks. And this is a group effort I'll be presenting, but the whole team in my branch and CPC in general contribute to all of this. Next slide, please. So just a quick outline. want to try to provide an overview of the CPC monthly and seasonal outlooks. First, interpretation is it's a major issue at times with a number of users and stakeholders, and so I'll talk more about that and some best practices, as well as what the release schedule is and our product suite in general. I will go through the latest outlooks for April, May, and June as part of the NOAA Spring Outlook. And then finally, more information about how the outlooks are actually made, some of the physical science basis for them, some of the climate drivers, and do a summary of some of the forecast guidance or tools that we use in informing the outlooks. Next slide, please. So next slide, doing an overview here. So there's a lot of information on this slide, but I just did want to show kind of an overview of the different products that we have. We do temperature and precipitation probabilistic products for a number of time scales, starting from the 6 to 10 and week 2 period that are released daily, 3 p.m. in the afternoon. Also, our week 3 and 4 outlooks, similar variables and format, but released one time each Friday at a similar time. What I'm going to be talking about today is our suite of monthly and seasonal outlooks, whether it be for temperature or precipitation or drought. And this is what's shown in the red box or the yellow transparency there. So for the monthly outlook, those are issued twice per month, sorry. On the third Thursday of the month is a seasonal outlook is released at a similar time, as is a seasonal drought outlook. And you can see that on the 5th column over. But one thing with the monthly temperature and precipitation outlook is that we do an update on the last day of the month for the temperature and precipitation and drought overall. And for the drought outlooks, these are drought tendencies, and I'll explain some of that as well. That's different from the temperature and precipitation. But this is kind of the general framework for the product suite we have. We have other products, of course, that I won't go into. Some of those are listed there. Next slide. So with respect to the monthly and seasonal outlooks, just from a basic level to start with interpretation, is that the outlook maps display the static maps that we show on our website, for example, are basically a tercile system, meaning we have above normal, near normal, or below normal as 3 categories. And the most likely category on these static maps is displayed, and it's as compared to the climatological distribution. So for the upcoming 30 or 90 days, we're looking at the 3-month or 1-month seasonal, mean temperature or total precipitation amounts over that 1 or 3-month period, whether they're going to be in the upper tercile, upper category, the middle category, or the below normal or bottom category. We also have a category for equal chances. I'll explain a little bit more about that on the next slide. And these forecasts are available in several formats, actually. Standard image format, binary data, but also very helpful formats like GIS and KML formats to be able to be shared across disciplines more easily. And that's just the website link there. Next slide, please. So on this slide, this is an example of a temperature outlook and a precipitation outlook previously from last year. And what I want to kind of demonstrate here is that many times folks that see a certain color on the map say, let's take a look in the Southwest, for example, where we have some orange shading. Often just a color, whether it be blue or in this case, shades of orange and red, folks can make a mistake that is 100% for that category. Obviously, many folks on the call are more savvy and certainly understand these outlooks better, and so know that that's not true. But once we also have an interactive display to try to force them to understand that the information, even though not displayed on its front end, the actual forecast has 3 category probabilities of the 3 different categories available. And so on the interactive display, which I'll show on the next slide, is basically a way of doing that. And so I've taken some examples of that approach for, like, say, the Southwest on the left-hand side. You can see the probabilities for above normal increase from the climatological probability of 33% to, say, 58%. And there's still non-trivial probabilities for near normal and decrease for the below normal, as indicated by the blue slice of the pie there. Similar for the below normal temperatures, in the top part of the image. And in this case, it's something important to point out is that even though the below normal category, the blue shading there in the pie chart, is the highest of the three categories individually, if you look closely, the probability of the other two categories verifying combined is actually greater than the favored category. So it's important for people to understand that these are probabilistic, okay, not deterministic. And these sort of tools and displays can help with some decision making when maybe the signals or the outlooks are not quite as strong in certain times of the year in certain locations. And another example real quick would be the precipitation for below normal precipitation in the southeast on the right-hand side, which shows strong tilt towards below normal in that one region, near 60%. So almost or approaching 2 times the climatological probability. And what's important there is that it's a relatively low odds for enhanced wetness in that area with respect to the outlook. Next slide, please. So this is an example of that display. I won't go too much in this, but this is the next sort of step in this hierarchy that we're trying to get users to understand. One is the static map that shows the most favored category. And then we have this interactive display where we're showing these pie charts and various things. In this part of our website, you can click in any region, kind of where that green sort of pin is, and the pie charts will change dynamically. And you also will get the normal and maximum and minimum temperature and the normal or climatological precipitation amount. And so it helps people to dynamically look to explain what I was showing in the last slide. Next slide, please. Also, I'm only going to be showing the first outlook later, but we do a whole set of outlooks out to about a year. And this is just an example of the temperature outlooks from one past forecast I think a few years ago now, where we actually had above normal temperatures favored as well as near normal temperatures and eventually below normal temperatures as we had relatively stronger El Nino event. And so we ended up having those sort of different categories. And then later on, you can see more of a trend towards above normal temperatures. So we have this for precipitation as well. The text discussion also accompanies each set of outlooks for both the monthly and seasonal temperature and precipitation, but also for the drought outlook. And that's just an example on the right. And this can be helpful. It looks like a lot there, but the idea is to provide the forecast basis, the reasoning behind why the maps look the way they do, not describing what the maps are. It's more of the forecast basis behind them. Next slide, please. So with respect to the current outlooks, if we move on to the next slide for the month of April, this was produced by Anthony Ortuzza, one of our forecasters. And so for April, it's kind of a continuation of a theme that was discussed by Chris in the beginning. For the month of April, generally favoring above normal temperatures across much of the east, southeast, with the highest odds across the parts of the Florida peninsula. And there's a number of factors in that, but I'll probably more talk about those in the seasonal outlook. For the precipitation was very challenging, which is normally the case, often the case, in the transition spring seasons. But we're favoring above normal precipitation, kind of on the northern edge of the southeast region, but probably outside. But also for a slight tilt towards drier than normal conditions for the month of April. As noted earlier, this is obviously a very dry time of the year. So near to below normal is likely to verify across that region if the forecast is successful. Next slide, please. So for the season as a whole, focusing on temperature, again, very similar. And there's a number of factors of some of the products that I'll show later on how the outlooks are prepared. But in this particular example, the dry conditions, tendency for continuation of heat, and overwhelming dynamical model support and other tools that we have. Really, there was not much guidance or forecast information that we had that showed anything but above normal temperatures, especially across the central part of the country and certainly the west, but also in the southeast, tended to tilt towards warmer than normal temperatures. For precipitation, it was a different story. A lot of uncertainty here, favoring above normal precipitation in AMJ across parts of Florida, the Southeast, and up into the Mid-Atlantic and Eastern Great Lakes. But you can see this is a pretty slight tilt in the odds. And one may say, well, this seems to be inconsistent with the April outlook, but not so. Is that we do favor most of the precipitation in that 3-month season is going to occur after the dry season period that, as David mentioned, and so the QPF, or the precipitation amounts, are likely to be above normal in our minds from some of the tools, and so we ended up favoring AMJ for wetness, enhanced wetness, as compared to even with a dry April. Next slide, please. So the drought outlook, this is a seasonal drought look from the same time, and just a quick instruction on this. This is the drought tendency or change by the time we get to the end of the forecast window, which is here in this case June 30th. And there's 4 categories: drought persists, drought remains but improves, drought removal likely, and drought development likely. And you can see across the Southeast, conditions are quite poor, so a very large area of drought remains but improves. Only very little in the way of drought removal. And as David said, things are likely to get worse before May 15th, most likely. And so we'll have to depend on the rainy season for first part of that, from approximately May 15th to the end of June, for that improvement. Next slide, please. So moving on to how the outlooks are prepared. Go to the next slide, please. So first, I wanted to kind of give a general overview of some of the climate drivers for the spring. Now, it's important to know there's others not listed here that would apply maybe in the winter and other seasons. But for the spring and making the outlooks that I showed earlier, certainly, as was mentioned, ENSO obviously plays an important part when active, and it's the biggest and most predictable interannual or seasonal related outlook predictor. But other variables during the spring are important, such as the boundary conditions. They have some memory in the Earth system, and so these can be sea surface temperatures that are more locally, but also especially land surface conditions with soil moisture, anomalies, vegetation stress, and variations. And also in some places, how the winter was with the snowpack, especially across much of the West, terrible season for snow, warm temperatures and dry conditions. And so these all can play into a role, maybe not so much in the Southeast for snow cover, but the land surface state with respect to soil moisture certainly does. We also make use of long-term climate trends, and that's basically a tendency for the average of the last 15 years compared to the 30-year average climatology that we're mandated to set our anomalies to and for verification. And finally, there is some longer-term climate variability that acts on more of a decadal time scale, but those are less influential in our outlooks. Next slide, please. So I'm not going to go through some of the process inputs with respect to ENSO. We use quite a bit of ENSO composites, also tools key to the ENSO cycle and forecast, and most folks are very familiar with those. So I'd rather spend some other time on some of the other information that we use as part of the process. There's actually quite a bit that does go into developing the seasonal outlooks. The focus on those is that we have a host of statistical and dynamical model forecasts that we use. Statistical meaning relating certain relationships of either observations at the current time or recent current time, going back a number of months, to what the eventual observed temperature and precipitation, seasonal temperature and seasonal precipitation categories might be in the future. We have dynamical model forecasts similar to weather forecast models, but these are short-term climate prediction models, can extend out to a year, multiple seasons. One of those is the NMME that some people might be familiar with, North American Multi-Model Ensemble, and et cetera. We do try to make an objective consolidation. We do this every month in real time of a combination of both more statistical tools as well as dynamical model forecasts. And then where needed in it, the forecaster will subjectively adjust the forecast as appropriate. because the first guess often is not necessarily can suffer for some artifacts, and is also can be overly biased due to hyperactive long-term trends in some of the dynamical model forecasts. The process starts with a discussion of our seasonal internal forecast team the Friday before the release date, where we review the current climate state, latest forecast information. We discuss our outlooks. We have 3 people make the forecast for the first lead to start with the consensus, and we basically discuss and argue how we want to change that and move forward. We do have a conference call that's open to all NOAA staff and others with a non-disclosure agreement, since these are embargoed forecasts. That occurs the Tuesday before the release on Thursday, and that's between 1 and 2:30 Eastern time. If you'd like to join that, please reach out to me. I'm very happy to add you to that list if possible. And the release date, of course, is the 3rd Thursday of each month. Next slide, please. So I'm not going to go through each one of these figures, so don't worry about that. But I just wanted to kind of show an overview of that. We do have a lot of dynamical model guidance or weather forecast models, but applied to a longer integration or forecast lead. And these are shown. These are from various operational centers and some research centers in this case, whether it be from the Europe ECMWF or the Europeans, as well as our Canadian colleagues, as well as other areas across the world. And we are able to use this information with the standard protocol and formats and data to produce an ensemble mean, which is in the upper left of all the inputs that we have. We then move towards calculating probabilities based on all the ensemble members. Each one of these models has different realizations for each one of them. So there's a set of mini set of forecasts for each one of these boxes in the final 2 rows, and those are combined, and the probabilities are calculated based on the model climatology. So that's an important point, is that we are in the left-hand plot and the middle plot, we're trying to remove the systematic error. These models have high biases that can develop relatively quickly. And so this is an attempt just to remove that right away to get more of an even playing field, that we're not looking at model error systematically in the forecast. The next step there on the right is a calibrated forecast where we link. Actually, I'll go to the next slide where I kind of explain this a little better. So this is what I was going through there. And what this is our switch to precipitation forecasts. And I already described the kind of the process for the left and the center box. But as we get to the right-hand box, we've removed the systematic error, but we need to calibrate the forecast to ensure or to try to optimize what we call forecast reliability, meaning the number of times or the percentage of times that we make forecasts of a given probability category. Let's say, how many times are they observed? And a perfectly reliable forecast is that you can get a diagonal line of that. And so that the process on the right tries to do that using historically based forecast skill for each model and the system, and also the forecast spread or ensemble spread at the time. And you can kind of see that, in doing that, you lose some of the signal, right? And you can see that on the right between the middle and the right-hand figures. For example, if you look at Southern Alaska, that forecast for below normal precipitation goes away. In other areas, the probabilities on the right are considerably muted than the ones in the middle. But it's a way of trying us to highlight and focus on where we feel like the best odds are for the official outlook. Next slide, please. And just quickly to go through this, we do have a number of, as I mentioned, statistical and empirical tools, but we also combine or produce hybrid information. One of those examples is where we can use bridging techniques. And what all that means is that you're using more predictable variables. For example, maybe say 500 height or the ENSO Niño 3.4 index that may be more predictable than, say, precipitation, which is highly variable in time and space. And sometimes you can get actually better forecast skill using that approach than directly going to the model precipitation forecast. So we do things like that. We have analogs, whether it be natural analogs or constructed analogs based on previous cases. And also the middle plot, just to highlight that, this is the AMJ precipitation trends. one of the reasons for the slight tilt and wetness in the southeast with AMJ is that there are it's weak, but there are positive trends there, and we had some dynamical model support. Next slide, please. And I'm not going to spend much time on this, but the point of showing this is that we try at the seasonal call that we have on Tuesday that I mentioned, we have a lot of information to present, so we try to organize it into various sort of snapshots where we can have discussions about it, the old outlook, the new outlook, and so on. And not all the information that we utilize is here, but this is one of the ways in which we try to help summarize it for the folks that are on the call for the preparation of how the outlooks are changing and get feedback in real time during that call. Next slide, please. So this is the summary and takeaway messages. I think for the sake of time, I'll leave this up here for questions. But the one thing I do want to highlight, though, is probably the fourth bullet, is that it's really important for stakeholders to know and to review and monitor some of the earlier outlooks that I mentioned, the shorter range outlooks, whether it be the week 2, week 3 and 4, for example, or the monthly. As of course conditions can vary, considerably during the season, and you can still make improve your situational awareness and decision making, even though it's not a seasonal outlook lead time. Things will change, so it's important I think to continue to keep those products in mind as well. And we're continuing to develop, doing applied research and development to further advance our product suite. And I'll turn it back over to Elliot or Chris. Thank you very much.
Morning, everybody. Thank you, John, and thank you to all of our presenters for this wonderful information. Again, if you have any questions, feel free to go into the Slido app and put them in there for our presenters. We have a few moments for questions. Should have started with this. My name is Elliot Wickham. I am NOAA's National Integrated Drought Information System, or NIDIS's Southeast Drought Information Coordinator. Thank you again to all our presenters. For our next webinars, we have some exciting topics coming up for April, May, and June. In April, we'll be talking about the agroclimate resource with data and tools. May, we'll be revisiting the 2025 hurricane season, which David actually talked a little bit about, but we'll be doing a deep dive into that. And then in June, we'll be talking about the outlooks for the 2026 Atlantic Hurricane Outlook. So let's go into the chat here and let's see if there's any questions. So are there retrospective analysis conducted to illustrate how climate, including temperature, precip projections, panned out to better understand uncertainties with those projections? I think, John, that's a question for you. If you're
Thanks for that question. Yeah, I didn't have time to show some of the forecast sales statistics, but we do have that information. In fact, we're upgrading our verification data sets and way we display it. But we do have we verify each forecast, whether it be monthly or seasonal, going back since the onset of these outlooks. And so we do have a general idea of how reliable or what the forecast skill is as a function of location, geography across our forecast domain, season, and also forecast tools themselves, as well as the official outlooks. But I didn't have time to kind of go through all that here, but I would happy to follow up if anyone would like to see that information.
Yeah, thank you for that. And just to point to John's talk, those calls on Tuesdays, him trying to pack everything in, both in terms of how they're made and how to use them, that's a lot for 25 minutes. Those calls on Tuesdays are an hour, I think, generally going through of how they're put together. So
yeah, about 90 minutes.
Fantastic job of synthesizing that and trying to walk through, making, condensing a very packed process. So I don't see any other questions in the chat, which is fine. If you think of any questions regarding the topics covered today, feel free to reach out to me and I can get that information to our presenters. You can reach out to me at my email, elliot.wickham@noaa.gov. And with that, since I'm seeing no other questions, we'll go ahead and end the webinar. So thank you again to all our presenters. Thank you for tuning in, and we will see you next month. Everyone have a fantastic rest of your day.